The garbage collector. This is one other important feature we did not mention in the list of features, okay, which you can add into. Garbage collector is used to remove objects which go out of scope, because in Java you can create an object by giving a new keyword, but you cannot actually remove an object or delete an object once it is done. You would either say free an object or delete an object, right, which is not allowed in Java, because see, in C or C++ you used to create an object, you used to free the object. But what if you didn't free the object? You had objects hanging around, so you would run into memory leakages. So to avoid such things, we have the garbage collector, which takes care of releasing objects as and when required, rather as and when they go out of scope. So let's take a look at the functionality of a garbage collector. A garbage collector is an application program which runs inside the JVM. When you start a JVM, the application, garbage collector application, also runs at that point. When you end your application, just before the JVM has to come out of its execution, the garbage collector execution is stopped, and then the JVM comes out of its execution. What the garbage collector does is, it collects objects that go out of scope. How does it exactly execute this? It uses the mark and sweep methodology. In a mark and sweep methodology, what it does is, it goes across your entire heap and checks which memory addresses are being referenced. Those memory addresses which are being referenced, it will mark, and those which are not being referenced, it will leave it unmarked. Once this process is done, then it goes back and collects all those memory spaces which have been left unmarked. During this process, when your application is running, let's say for all your objects a memory has been allocated and it's been deallocated because your object is no longer being used, so your garbage collector collects objects which go out of scope, you end up getting fragmentation in the memory space. So how do you execute defragmentation on this memory space? This is also done by the garbage collector. There are two methods that are used. Either it uses the shift method or it uses the copying method. In the shift method, you have objects which have been allocated this chunk of memory. As and when objects go out of scope, the memory space is collected by the garbage collector. Then the defragmentation is run on the memory space. In case of shift methodology, for defragmentation, what it does is, it checks this particular memory space is free now. It goes to the next memory space and checks whether if it has been allocated. If not, moves to the next memory space. Now this has been allocated. Now what it does is, it takes this content, shifts it to this empty space, moves it to the empty space. When it does this, there would be some object variable, let's call it as A1, which might be referring to this memory space, let's call it as 1000. There might be another object variable A2 which is also pointing to that memory space 1000. A3 which is also pointing, possible. You could have multiple object variables pointing to a single memory space, let's assume. When you make this shift, let's say this is a shift to an address space called 500. In all these memory spaces, we need to change the address to 500. So it goes and changes the address to 500 here, 500 here, and 500 here. So depending on how many object variables are referring to the same address space, to all those memory spaces, the change of address has to be implemented. Either this method can be used, or in the change of memory spaces, or what it does is the JVM could be implemented such that all these memory spaces are actually, that is all the object variables are actually referring to one indirection, okay, and this indirection, let's call it as n, and this n was the one that was referring to 1000. So let's say this n is at memory space 50, so all these three variables are referring to 50, that is here, and this n is referring to 1000 here. So when I shift this content from 1000 to 500, how many changes do I need to make? Only a single change, that is at n. So I could have a indirection for all these object variables, so the change of address can be implemented at only a single space. So depending on the JVM implementation, it could either be having this indirection or without the indirection. So using the shift methodology, the JVM could be implementing defragmentation, or we said it can also be using a copy methodology. In a copy methodology, what happens is you have two chunks of memory. It takes the first chunk, two chunks of equal memory. In the first chunk, it will start allocating memory for objects. Once this chunk is full, and the garbage collector, when it executes and collects objects or memory spaces, then what happens is it moves the content from the top chunk to the bottom chunk, and further memory allocation will be done in the bottom chunk till it gets filled in. And again, it is possible that we have collected some memory spaces, and again it moves the content back to the top chunk of memory. So it goes on likewise. The problem with the shift methodology is that it is more time consuming, whereas here it is more memory required. So this is how a garbage collector works.